now we get to the meat and the heart of what we've been talking about with expanding our binomials. And we're on to example number 6. So you got to pay careful attention. And Mr. Nzuza and I just wanted to remind you guys that when you guys are watching these videos, okay, this is not supposed to be like when you're in a live lecture when you just let the lecture play on and you just take notes and then you don't understand what the teacher is saying, so you just kind of take notes and then hopefully like you figure it out. You guys need to be pausing the videos, thinking about the calculations we're doing and the things that we're saying, and things that don't make sense, you need to be highlighting and creating questions. We're not seeing many questions from you. And what we're noticing is that you guys are coming to class and you're just saying, hey, honey, help on number 5. And they're like, well, what have you done? Well, I don't know how to do any of it. Well, that just means that you didn't take any notes. You're not even thinking about it. So the whole point of this whole flipped classroom thing is that you are learning and doing the best you can at home so that when you come to class, most of the time it's just spent working on problems, getting your questions answered. We're not supposed to be teaching you the material when you're in class, by the way, okay? That was the traditional model, where you come to class, okay, teacher, teach me how to do this. No. We're doing the other way around. You learn at home, then you come to school with questions. Not, I don't know how to do it. Or, I don't get anything. There's no way you got the trigonometry pre-calculus not knowing anything. So try a little harder. Go back over the video 5-6 times if you have to. And please start coming with some questions. All right? And I'm not trying to be a jerk right now. It's just that we're not seeing the system. We're not seeing the vision that Mr. Nzuza and I had when we wanted to start this. Okay? And so we want to continue this process, but just start to make those changes, because you're going to see your knowledge increase and your grades go up if you follow the process that we're showing you. So that's from my heart and from Mr. Nzuza. We really want you guys to be successful in doing these videos. Okay, so right now we're in example number 6, and we want to find the 6th term of a plus 2b quantity all to the power of 8. Okay? Now, yes, you could use Pascal's triangle. That means you would have to derive the whole thing all the way down to the 8th term and all that kind of stuff there. But you know what? When these numbers start to get past 4, 5, 8, maybe sometimes 12, 15, there's no way that you're going to want to draw and create a triangle that much. The numbers get too big and out of control. So this is now when we officially have to start using the binomial theorem. Okay? So if I want to find what is the 6th term of this guy right here, we're going to use this. Okay? So this will give us our coefficient, and this right here is going to give us what our exponents will be. So let's start with our coefficient. Okay? Well, what's going to be our coefficient of the 6th term? Well, let's think about this. Okay? N is always this number right here, right? So that one is probably the easier one there. Okay? And our R is what term number are we at? Well, they want us to find the 6th term. But remember, R starts with 0. So really, the first term is 0, and then 1, 2, 3, 4, 5, 6. So really, the little trick is you always do 1 less. So really, we're going to choose 5. Okay, and that should make sense. If I have the 6th term, 1, 2, 3, 4, 5, 6, that means this is R's 0, 1, 2, 3, 4, 5. See? So you always do 1 less for the R. Okay? So this is going to give us our coefficient, but maybe not the whole coefficient, because we still have to multiply all this out, right? So I'm going to leave this as 8 choose 5, okay? And now, okay, let's check this out, because we haven't officially told you how to use this. If I want to find what's my exponent of x, you just take x, in this case, okay, so this is referring to x plus y, by the way. So x refers to just our first term. So our first term is a, so you take your first term, a, and to the n minus r. So my first term is a to the n minus r to the 8 minus 5. Okay, so it's kind of cool. Our binomial theorem gives us what our exponent is going to be. And then our y term, but in this case it's our 2nd term, which is 2b. So 2b to the power of just our r, which is going to be 5. Okay, now we're going to show you how to do this on your calculator, okay? And because, I mean, doing this by hand, I mean, does kind of take quite a length, a bit about a time. So just go ahead and write this down right now. But if you kind of want to know right now, we're going to show you in class though. But you would just, if you were to do this right now, like you would press 8. Okay, press 8. Press the math key. Press math. Okay, and then you're going to scroll over to where it says probability. So scroll over to where it says PRB, which stands for probability. And then you're going to see a function that says this. And choose R. Okay, choose that guy right there. And then right now your calculator should look like this. 8 NCR. All you got to do now is just put in 5. And then that's going to pop out this number. So I'm just going to go ahead and use my calculator to generate this right now. Okay, so this whole number right here is just 56. So a really nice, powerful tool there. Okay, and then our A is 8 minus 5, so that's A cubed. And then here, 2 to the power 5. 2 times 2 is 4, times 2 is 8, 16, 32. So that'll be times 32 to the B to the 5. Oops. B to the 5. So notice, really, this wasn't our coefficient, right? Because now we have to multiply 56 and 32. We're going to multiply those two guys right there. So 56 and 32 is going to give us 1,792. And then A to the power 3 and B to the power of 5. And this right here would give us our 6th term of this binomial right here. And I'm just getting real tired. I need a tag team. And Azusa, where you at, Azusa? Oh, tag team. Oh.
Hey. All right, guys. We're going to talk about a little bit of part B here, which is a pretty crazy problem, which says, find the coefficient of the term. Oh, the term is what? A to the 6th, B to the 5th, in the expression 2a minus 5b to the 11th. Well, let's see. So we want to know the coefficient. Now, remember the coefficient, we use Pascal's triangle before to get the coefficients. However, if you notice over here, the power is 11. That means we're on the very far down, right, on the Pascal triangle. So like Mr. McCaffrey said, it's going to get humongous. So perhaps it will be a good time on this one to actually use our theorem to derive the term that we need, okay, or the coefficient that we need. So let's go ahead and think about what we have here. First of all, this is saying that we want the coefficient. So we want to know what goes in front of that thing right there. That's what we want. So first of all, we need to figure out, well, what term is this? Remember our N, choose R. So we want to figure out where are we in that row of the 11th power. So let's see. So now, remember the exponent is 11, so which means N is 11, right? The problem here is that we know this is 11. That's the easy part. The hard part is, let's think about, well, which term am I in? So let's think about it. All right, well, let's see. We started with 11, and remember how since this is a 6, we're counting down all the way from 11, right? All the way from 11. So let me kind of write them out as we go, and then we'll figure out what term gets us here, correct? So here we go. So let's see. This is A to the 11, A to the 10, A to the 9, A to the 8, A to the 7, A to the 6, right? So now, let's see. We have 1, 2, 3, 4, 5, 6 terms. However, remember, do we actually call this our first term? No, we always start with what? The magic donut, right? The 0, yes. So this is actually not our first term. This is actually term number 0, term number 1, 2, 3, 4, 5. So actually, this is not the 6th term. This is actually the 5th in our R, in terms of R. So if you count them, yeah, you're saying, hey, Mr. Tunza, but those are 6 there. Yeah, there are 6. But remember, when we're counting our terms, we always start with the very first one being the 0, right? So it's the 0 term, the first term, the 2nd, the 3rd, the 4th, the 5th. So in reality, this is 11 choose 5. So this is 11 choose 5, not 11 choose 6. Okay, I hope that made a little bit of sense, what I'm trying to get at here. So I'm going to go ahead and get rid of this, and then we're going to go ahead and apply this to this whole thing. Okay, So we'll see. We'll see what we get. Okay, so here we are. So 11 choose 5. This is going to give us the coefficient. However, remember, this is the coefficient of this thing over here. So you need to take that into consideration when you're figuring out. Because remember from the problems before, you have to do the same thing or do that exponential stuff. Well, let's go ahead and do it and see. So here we go. 11 choose 5 means 11 factorial over what? N minus r, right? Which was 11 minus 5, which is 11 minus 5 is 6. So 6 factorial times r factorial, which is 5 factorial. Boom. So this means 11 times 10 times 9 times 8 times 7 times 6. Oh, factorial. I'm going to stop there just because since there's a 6 factorial there, those guys are going to go away. So we end up with 6 factorial over 5 factorial. And look, right there. Cool. So let's finish this up then. This 5 factorial is actually 5 times 4 times 3 times 2 times 1. And let's do some canceling out or some dividing out. Or I'm just going to do it in the calculator and simplify because I don't want to keep you on the computer forever. So, and actually, like Mr. McCaffrey said, you could use the calculator for all this hairiness, like he likes to say. But, well, you know, it's a matter of what you prefer, I guess. 3 times 2 times the 1. I'm going to close the parentheses. And we end up with 462. So my coefficient is 462, right? However, yeah, the coefficient is 462, but what do we still have to take into consideration? These numbers here, right? We have to take these into consideration, which means that we have to take actually the 2a now and also do what to it? Remember, where's this at? Where's this a at in terms of our place? Remember, it was when we started was the 11th power, the 10th, the 9th, the 8th, the 7th, the 6th power, right? So it was to the power of 6. So we got to take this guy to the power of 6. Okay, so 2 to the 6th power, let's find out what that is. 2 to the 6th power is going to be 2 to the 6th power. It actually gives you 64. So what ends up happening is, let me get rid of this now. So far we have this 462. Now it was the 64 for that. Correct? You guys are with me? 64 came from this guy right here. Okay? Now we got to do the same thing for this guy over here. So the b is actually also going to be what power? To the power of, remember the b goes backwards, right? So, or follow the binomial theorem over here. And I'm stuck, dude.
That's your R. It's your R, right?
It's your R. Yes, it's the R. Dude, I'm stuck. I lost my mind, dude. It wasn't the same thing, right?
It is the same thing.
I know it is.
Okay.
So it's
N
5
minus
R.
R. So like N minus R, 11 minus 5 is
Damn
6.
it! It was the same thing. So it's just 5 to the same power.
Yeah.
Shoot. Dude, just edit that.
Ah. You want to do that? You want to do that one over again?
Yeah, dude. Damn, it was just the same thing again, man. I don't know what happened. What went wrong?
That's because like you derived that 64 by intuition, and then you're like, oh, but what about now the other one?
It's going backwards.
You should have used this though the whole
It's
time.
the same term.
It is the same term,
It's the same term.
but this is how you always know where you're at. So that's why this is 6.
Yeah.
And plus, you should look right here. That was 6. There's a 4, 5, but.